The National Electrical Code, or NEC, does not have specific rules about using round boxes with extension rings and stud walls for wall sconces. However, there are some general rules that might apply. NEC Section 314.20 says that junction boxes have to be suitable for how they are being used. Also, NEC Section 314.23 says that junction boxes have to be securely attached to the structural parts of the building. Industry standards and what the box maker says can help you know if using junction boxes with extension rings is okay. The company that makes the box might have information about how it should be used. The inspector might be reading the NEC rule about suitability, NEC Section 314.20a, in a way that makes them think you cannot use round boxes with extension rings for wall sconces and stud walls. They might say that the box and ring were not made for this and might not hold the sconce well enough. But plaster frames are often used to make junction boxes longer and hold wall sconces and plaster walls. A round box with an extension ring could do the same thing in a stud wall. If the box and ring are attached to the studs the right way, they should be able to hold a wall sconce without problems. If the box and ring are good for how they are being used according to NEC Section 314.20a, and they are attached securely according to NEC Section 314.23a, they should not break the NEC rules. If you do not have specific details from the maker of the box or industry rules, it can be hard to say for sure if a 4" by 2 1/8" round box with a 1.5" extension ring can hold a wall sconce well in a stud wall. But there are reasons to think it could work and still follow the code. It might help to talk to the inspector more about this. Explain your view and give them any information you have found. It's crucial to delve deeper into the NEC requirements to fully understand the situation. The NEC provides a comprehensive set of guidelines for electrical installations, and while it may not explicitly address every specific scenario, its general principles offer a framework for safe and compliant practices. Let's break down the relevant sections and explore their implications for this particular application. Firstly, NEC Section 314.20a, which mandates that junction boxes be suitable for the conditions of use, is a critical consideration. This requirement emphasizes the importance of selecting electrical components that are appropriate for the environment and application in which they will be installed. In the context of a wall sconce installation, several factors contribute to the suitability of the junction box. These factors include the weight and size of the sconce, the type of wall construction, and the potential for exposure to moisture or other environmental hazards. The junction box must be capable of withstanding the anticipated load and environmental conditions without compromising its structural integrity or electrical safety. Secondly, NEC Section 314.23a, which stipulates that junction boxes be securely fastened to structural members of the building, is equally important. This requirement ensures that the junction box is firmly anchored to the building's framework, preventing it from shifting or becoming dislodged over time. Proper fastening is essential for maintaining the stability of the electrical connections within the box and for preventing strain on the wiring and associated components. In the case of a wall sconce installation in a stud wall, the junction box must be securely attached to the studs to provide adequate support for the fixture. This typically involves using screws or other fasteners that are specifically designed for use with wood or metal studs. In addition to these NEC requirements, it's also important to consider industry standards and manufacturer instructions when evaluating the suitability of a round box with an extension ring for supporting a wall sconce. Industry standards, such as those published by organizations like the National Electrical Manufacturers Association, or NEMA, provide guidance on the design, construction, and performance of electrical equipment. These standards can offer valuable insights into the intended applications and limitations of specific products. Manufacturer instructions, on the other hand, provide detailed information on the proper installation and use of their products. These instructions often include specific recommendations for mounting and supporting the equipment, as well as warnings about potential hazards or limitations. By carefully reviewing industry standards and manufacturer instructions, you can gain a better understanding of the capabilities and limitations of the round box and extension ring in question. This information can help you determine whether the components are suitable for supporting the wall sconce in your particular application. Furthermore, it's essential to consider the inspector's interpretation of the NEC requirements. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations comply with its provisions. However, interpretations of the code can vary, and inspectors may have different opinions on the suitability of certain materials or methods. In this case, the inspector may be concerned that the round box with an extension ring is not specifically designed for supporting wall sconces and may not provide adequate support for the fixture. They may also be concerned that the installation could violate other NEC requirements, such as those related to box fill or conductor bending radius. It's important to engage in a constructive dialogue with the inspector to understand their concerns and to present your arguments in favor of the installation. Be prepared to provide documentation, such as manufacturer specifications or engineering calculations, to support your position. You may also want to consult with other electrical professionals or code experts to obtain additional opinions on the matter. Now, let's delve into the arguments in favor of using a round box with an extension ring for supporting a wall sconce in a stud wall. One compelling argument is that this type of installation is similar to using plaster frames to extend junction boxes and support wall sconces in plaster walls. Plaster frames are commonly used in plaster wall construction to provide a stable mounting surface for electrical fixtures. They are typically attached to the junction box and then embedded in the plaster, creating a flush finish. A round box with an extension ring can serve a similar purpose in a stud wall, providing a stable mounting surface for the wall sconce and allowing for a clean, professional-looking installation. Another argument in favor of using a round box with an extension ring is that it can provide adequate support for the wall sconce if the box and ring are properly secured to the studs. As mentioned earlier, NEC section 314.23 requires that junction boxes be securely fastened to structural members of the building. If the round box and extension ring are firmly attached to the studs using appropriate fasteners, they should be able to support the weight of the wall sconce without any issues. In addition to providing adequate support, a properly installed round box with an extension ring can also help to ensure code compliance. As long as the box and ring are suitable for the conditions of use, as required by NEC section 314.20a, and securely fastened, as required by NEC section 314.23a, the installation should not violate the NEC. It's important to note that the suitability of the box and ring may depend on several factors, such as the weight and size of the sconce, the type of wall construction, and the environmental conditions. Before proceeding with the installation, it's advisable to consult with an electrical professional to ensure that the components are appropriate for your specific application. In conclusion, while the NEC does not specifically address the use of round boxes with extension rings for supporting wall sconces and stud walls, the arguments presented above suggest that it can be a reasonable and code-compliant solution. However, it's essential to carefully consider the NEC requirements, industry standards, and manufacturer instructions to ensure that the installation is safe and effective. It's also important to engage in a constructive dialogue with the electrical inspector to address any concerns and to obtain approval for the installation. If you are unsure about any aspect of the installation, it's always best to consult with a qualified electrical professional. They can provide expert guidance and ensure that the installation meets all applicable codes and standards. Furthermore, let's consider some practical tips for installing a round box with an extension ring to support a wall sconce in a stud wall. These tips can help you ensure that the installation is done correctly and safely. Firstly, before you begin any electrical work, it's essential to turn off the power to the circuit at the breaker box. This will prevent electrical shock and ensure your safety. Secondly, carefully select the appropriate round box and extension ring for the application. Consider the weight and size of the wall sconce, the type of wall construction, and the environmental conditions. Choose components that are specifically designed for supporting wall sconces and that are suitable for the intended use. Thirdly, locate the studs in the wall and mark their positions. Use the stud finder to accurately locate the studs and mark their positions with a pencil or marker. This will help you ensure that the round box and extension ring are securely attached to the studs. Fourthly, cut a hole in the wall for the round box. Use a drywall saw or a utility knife to cut a hole in the wall that is slightly larger than the diameter of the round box. Be careful not to damage any wiring or other components behind the wall. Fifthly, install the round box in the hole and secure it to the studs. Use screws or other fasteners that are specifically designed for use with wood or metal studs. Make sure that the box is flush with the wall surface and that it is securely attached to the studs. Sixthly, attach the extension ring to the round box. Use screws or other fasteners to attach the extension ring to the round box. Make sure that the ring is properly aligned with the box and that it is securely attached. Seventhly, wire the wall sconce according to the manufacturer's instructions and NEC requirements. Carefully connect the wires from the sconce to the wires in the junction box, using wire connectors that are appropriate for the wire size and type. Make sure that all connections are secure and that the wires are properly insulated. Eighthly, mount the wall sconce to the extension ring. Use screws or other fasteners to mount the wall sconce to the extension ring. Make sure that the sconce is securely attached and that it is properly aligned with the wall. Ninthly, turn on the power to the circuit at the breaker box and test the wall sconce. Make sure that the sconce is working properly and that there are no electrical hazards. Finally, if you are unsure about any aspect of the installation, consult with a qualified electrical professional. They can provide expert guidance and ensure that the installation meets all applicable codes and standards. Remember, electrical work can be dangerous, so it's important to take all necessary precautions to ensure your safety. Always turn off the power to the circuit before you begin any work and consult with a qualified electrical professional if you have any questions or concerns. Furthermore, let's address some common concerns and misconceptions about using round boxes with extension rings for supporting wall sconces. One common concern is that the round box and extension ring may not be strong enough to support the weight of the wall sconce. This concern is valid, as some wall sconces can be quite heavy. However, if the round box and extension ring are properly selected and installed, they should be able to provide adequate support for most wall sconces. It's important to choose components that are specifically designed for supporting wall sconces and that are rated for the anticipated weight. Another common concern is that the installation may not be code compliant. As mentioned earlier, the NEC does not specifically address the use of round boxes with extension rings for supporting wall sconces. However, if the installation meets the general requirements of the NEC, such as those related to suitability and secure fastening, it should be considered code compliant. It's important to consult with an electrical inspector to ensure that the installation meets all applicable codes and standards. A related misconception is that using a round box with an extension ring is somehow less safe than using a different type of junction box. This is not necessarily true. As long as the round box and extension ring are properly selected and installed, they can provide a safe and reliable mounting solution for wall sconces. In fact, in some cases, using a round box with an extension ring may be preferable to using a different type of junction box. For example, a round box with an extension ring may be easier to install in certain types of walls or may provide a more aesthetically pleasing finish. Another common misconception is that using a round box with an extension ring is always cheaper than using a different type of junction box. This is not always the case. The cost of the round box and the extension ring will depend on several factors, such as the size, material, and brand. In some cases, using a different type of junction box may be more cost-effective. It's important to compare the costs of different options before making a decision. In addition to addressing these common concerns and misconceptions, it's also important to consider the aesthetic aspects of the installation. The round box and extension ring should be installed in a way that is visually appealing and that complements the style of the wall sconce. The extension ring should be flush with the wall surface and should be painted or finished to match the surrounding wall. The wall sconce should be mounted in a way that is symmetrical and balanced. By paying attention to these aesthetic details, you can create a wall sconce installation that is both functional and beautiful. Finally, let's reiterate the importance of consulting with a qualified electrical professional before undertaking any electrical work. Electrical work can be dangerous, and it's important to take all necessary precautions to ensure your safety. A qualified electrical professional can provide expert guidance and ensure that the installation meets all applicable codes and standards. They can also help you troubleshoot any problems that may arise during the installation process. By working with a qualified electrical professional, you can ensure that your wall sconce installation is done correctly and safely. To summarize, the use of a 4" by 2 1/8 inch round box with a 1.5 inch extension ring to support a wall sconce in a stud wall presents a situation where code interpretation and proper installation techniques are critical. While the NEC does not explicitly forbid this practice, adherence to general requirements regarding suitability, secure fastening, and manufacturer instructions is paramount. The inspector's concern highlights the importance of ensuring that the chosen components are not only capable of supporting the weight and size of the sconce but also appropriate for the intended environment. The arguments in favor of this method often hinge on the similarity to using plaster frames in plaster walls, where extension rings provide a stable mounting surface. However, in a stud wall, the secure attachment to structural members is crucial to ensure that the assembly can bear the load safely and reliably. To navigate this situation successfully, it's recommended to engage in open communication with the inspector, providing documentation and evidence to support the chosen method. This may include manufacturer specifications, load calculations, and examples of similar installations that have been approved in the past. Additionally, consulting with other electrical professionals and code experts can provide valuable insights and perspectives. Ultimately, the decision of whether to approve the installation rests with the inspector, but a well-reasoned and documented argument can significantly increase the likelihood of a positive outcome. Remember, safety and code compliance should always be the top priorities, and any doubts or concerns should be addressed through thorough research, consultation, and adherence to best practices.